In today's lecture, we will be discussing the ideal and the non-ideal sources. The non-ideal sources are also known as the practical sources. The electrical sources are the devices that convert other forms of energy to electrical energy. The other forms of energy may be mechanical, kinetic, chemical, potential, energy, etc. The sources are the active elements of the electric circuits because they produce electrical energy, and any electrical source can be classified as voltage and the current sources. Theoretically, there are two types of voltage sources which are available in any electrical network. These are ideal voltage source and the non-ideal or the practical voltage source. Now, what do we mean by an ideal voltage source? An ideal voltage source is a source whose terminal voltage will remain constant irrespective of the load connected to it or the current supplied by it. And this is only possible if the resistance of the source is zero. That is, if the internal resistance of the source is zero. The ideal voltage sources are only theoretical and it cannot be developed in the laboratory. An ideal voltage source doesn't have any internal resistance, and so no voltage drop takes place across the resistance, as a result of which the terminal voltage remains constant. Hence, an ideal voltage source is a source which has zero internal resistance. That is, the value of Ri will be equal to 0, where Ri is the internal resistance of the source. From the figure 1 and 2, we find that this is an ideal DC voltage source and this is an ideal AC voltage source. The internal resistance of these two sources are 0. That is why they are known as ideal voltage source. So in this case also Ri is 0 and in this case also Zi is 0. That is, the internal impedance is 0 in this case and the internal resistance is 0 in this case, because this is a DC circuit. Since this is an AC circuit, so the internal impedance of this source is 0. So if we measure the voltage across these two terminals, then the voltage across these two terminals will be the same as the voltage of this source. So we find that this is an example of an ideal voltage source. Similarly, in this case also we find that the voltage across these two terminals will be the same as the voltage of this voltage source. Now from the figure 3, we find that if we draw the plot of the voltage and current of an ideal voltage source, then we will get a straight line whose value will be constant to Vs. So we find that the terminal voltage of an ideal voltage source remains constant irrespective of the load current or the current supplied by it. That is why the graph is a straight line parallel to this current axis. So we can see that an ideal voltage source can also be called an independent voltage source because its value of voltage remains constant irrespective of the current drawn by it. In the next lecture, we will be discussing the practical voltage source and the ideal current source and the practical current source.